Hi, hello friends. Welcome to the today's session and welcome to Unacademy. Welcome to Srinivasrao Sir classes. Dear friends, we are going to learn about the different functions of layers in OSI and TCP/IP. So before entering into the discussion, we will say our anthem. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, Unacademy has created a wonderful platform for online content. So you and me are in the route which is created by Unacademy. As we know that Unacademy is providing top quality content from top quality educators. So please like all our videos and subscribe to our channel and get admission into Unacademy for furthermore lectures in different subjects. So myself is Srinivasrao Sir, having more than 15 years of experience in the GATE with the various subjects. I taught in many premium academies with a high success rate. Also had industry experience as a database admin and a system analyst. Dear friends, I can proudly say that many of my students completed their post-graduation in premium institutions after cracking GATE examination. So GATE examination is a benchmark being engineering student so that you can able to further grow topmost levels. So Unacademy, apart from top quality content, also offering discounts. So by using my referral code, you are going to get a maximized discount. This is for fourth year subscription. Fourth year can opt for this subscription and you are going to get a maximized discount on this fee. And my dear friends, there is a other kind of a subscription that is a 24-month subscription. So that also you're going to get maximized discount by implementing my referral code. And this can be opted by first, second, third, and fourth years. You need to start your GATE training program from the first year itself. Therefore, you are going to have a good grip on the core subjects like data structures, TOC, compiler, DBMS, CNOS, and others. So once you get subscribed, you are going to be called as a plus student and a prime student. Whatever the content is there in Unacademy portal, all you can able to access like a live sessions, like quizzes, and mock test, and many others. Dear friends, if you are having any doubt, just fill the form here. Then you are going to be directed by educator. Educator is going to clear all your doubts regarding your subscription and regarding your any kind of examination. So let's crack GATE CSC is our YouTube channel. Subscribe to our YouTube channel. Use my referral code to get the maximized discount and hit the bell icon for the latest notifications and updates. Now let us start our today's agenda, that is open system interconnection, layers of functionalities. As we know, OSI is provided by ISO, which is completely theoretical model. So it is not implemented, it is a theoretical model. That's why it is a reference model to IEEE. That is provided, IEEE is provided is a new implementation model that is called TCP/IP. So the reference model for TCP/IP is your OSI. So first of all, let us speak about OSI. So when you talk about the OSI, it is divided into 7 layered structure, and each layer is performing its own functionalities. These 7 layers are grouped into 3 varieties: group 1, group 2, and group. So group 1 layers are topmost layers, higher level layers, application, presentation, session, and the group 2 layers are lower layer layers, network, data link, and physical. And the group 3 layer is called as transport layer. So what is the use of this transport layer? Why we have divided it as a separate alone? Because this particular layer is trying to have an interface between uppermost layers and lowermost layers. So these are your uppermost layers and these are your lowermost layers. There is an interface between this and this is transport layer. So transport layer is performing as an interface between topmost 2 layers, that is uppermost layers and bottommost layers. Why they are being divided into 3 categories? That is, if you are saying that uppermost layer is a purely software based, if you are saying the lowermost layers are nothing but hardware and software enabled, that's whatever software based layers are informing, that is being converted by your transport layer, the down the layer. And these layers, whenever you are talking, so it divides the communication process into 7 layers. So each layer performs a specific functions we are going to discuss today. So the last 3 layers are passing traffic through network. That's why they are called hardware and software layers. They are also called as interlinked layers or layers chained to each other. And topmost 4 layers are involved to complete the process. They are called end-to-end layers or user support layers. So the intermediate nodes usually involve in bottom 3 layers only. Last session I discussed about this, how the layers are being organized whenever you are keeping some kind of hardware medium. So all intermediate nodes are performed at bottom layer 3 layers only. They are internet layer, data link layer, and physical layer. So communication within the layer is independent operation of the layer that is being used. So if you look at this diagram, so every layer is going to have protocol data unit. So already I discussed in the last sessions what is APDU, what is TPDU, what is NPDU, what is DPDU. So APDU, whenever you are talking, this is in the form of message. TPDU, whenever you are talking, this is in the form of a segment. NPDU, which is in the form of a packet. DPDU in the form of a frame. And physical layer protocol data unit in the form of bits. So these are the protocol data units. And the last 3 layers are interlinked each other or chaining to each other because they are dealing with the medium. So whenever you keep some intermediate node, these nodes are being interacted with them. But last topmost 4 layers are end-to-end layers. Directly they are interacting from sender to the receiver without having any interaction with intermediate nodes. And each layer is having its own peers, protocol peers. It is running high level protocols like this, and TCP is running TCP and UDP, and IP is running its own protocols. Data link layer is having its own protocols. Dear friends, we know that lower layer is going to provide the services to upper layer. Layer 6 provides services to layer 7. Layer 5 provides services to layer 6. And layer 4 provides services to layer 5. Layer 3 provides services to layer 4. And layer 2 provides services to layer 3. And layer 1 provides services to layer 2. So this is how it happens. Lower layer provide the services to upper layers. 4 will provide 5, 3 will provide to 4, and 2 will provide to 3, and 1 will provide to. Now, first let us start the functionalities of each layer. Whenever you talk about the topmost layer, that is application layer, which is a direct interface to the user. You see this diagram, you will understand. Application layer is a topmost layer which is directly interacting with the sender and receiver only. Therefore, it is called user interface layer. It deals with the high level protocols which never includes intermediate nodes. It is a purely software based. Its PDU is APDU in the form of unlimited message. And your application layer supports multiple number of protocols. So these are all the features of application layer. It is embedded in software packages only. So whenever you install a browser, the browser is inbuilt is associated with HTTP protocol. So you need not to separately install it. They are all available in software packages. When you are configuring Gmail, you are going to install SMTP protocol, which is one of the protocol of your application layer. So let us see its important points. It is employed in software packages. So application layer uses whatever the user is sending the data. The data, first of all, it try to communicate with the other particular application layer, and it is trying to communicate with the other application layer, and it is trying to send the data to presentation layer, because the presentation layer is involved in the real-time encryption, compression, decryption formats. Whenever you talk about an app on your mobile, Android app, that's nothing but you are trying to communicate from your app client to app server. That means it's completely app to app based, application to application based. So without application layer, you cannot able to communicate with the user. Whatever user wish to send, the data is going to be presented at application layer only, which is deals with a multiple number of application layer protocol. So it is an interface between user and the downward layers. So it is a purely software based. So you want to communicate from one particular layer to other particular layer. So application to application, it is going to communicate. So there will not be any kind of a cross communication. And whenever you are sending the data to downward layers, the application layer is going to add a header. The header consists of protocol control information, which consists of what kind of protocol you are using and what is the length of the data you are sending, whether you are using connection oriented or connectionless. Such kind of information is available in that header, which is nothing but your protocol control information, which is associated with your message. So it deals with the high level protocols. Its PDU is APDU, which is in the form of message. And this APDU is unlimited. There is no restriction on this. Whatever data the user would like to send, you can able to put it on the topmost layer, that is nothing but application layer. So what are the functionalities? Like I say, file transferring you want to do, uploads and downloads, and you want to send a mail, electronic mail, which is SMTP protocol, and this is your file transfer protocol, and message transferring and browsing can able to do with the help of HTTP protocol. So what are the different kinds of protocols you can able to run? So FTP, DNS, and net SNMP, mail transfer protocol, gateways, and web browsers, NFS, and many others. These are all the real-time example services at your application layer. So my dear friends, we are all going to see that whenever sender is sending a mail, for example, I am sending a mail, but we don't know that how this is going to be happen. Simply we compose and push that mail to the other party. But there is a lot of action is there. First of all, the application layer takes your data and it is trying to implement SMTP client and it is trying to communicate with SMTP server. So SMTP client is a one app. You are trying to communicate with SMTP other particular application. It's a completely application oriented only. And after communication is established, then to that particular message or your to mail, it is going to add its own header that is called AH. Now this data will come to transport layer. Or if you are including a presentation layer, the data is going to come to presentation layer. So this is how, this is a one app application and this is a one app application which is a purely software based. It doesn't mind that there are some intermediate hardware is available. Now, once you come to the presentation layer, nowadays we know whenever you are sending your data through medium, whenever you are sending your data through medium from topmost layer to bottom up layer, that is a physical layer is pushing your data that is in the form of a signal. This medium is insecure because hackers or intruders are lying there. They are trying to steal your data. That's why whatever application layer is sending, that is a purely direct data. So that is being encrypted and compressed using presentation layer. The presentation layer is try to present your data in a different forms. For example, you say, I want to encrypt this. So the encryption is the responsibility of your presentation layer. For example, I want to do compression, and the compression is another responsibility by your presentation layer. The presentation layer sees that how your data can be transmitted using a different kinds of formats. So what is the real-time example? Whenever I am attaching some kind of images on your WhatsApp, whenever you just dump some images onto your WhatsApp, you all know that they are going to be what? Compressed. Automatically they are being compressed because WhatsApp has got that facility. So they are going to be in the form of compressed. So these compressed images are called as lossy formats. So whether to send your data in the form of lossless format or lossy format, that is decided by your presentation layer. But whenever you are sending your images or anything, whatever it may be through mailing, then they are not in a compressed manner. They are directly available. They are in uncompressed model. So I can able to say that they are under lossless formats. So that's why presentation layer is going to involve to perform. One is secure by keeping encryption. The other one is a compression, by seeing that your bandwidth is not that much wasted, that much used to transfer your data. So compressed tools are like WinZip, or like WinRAR, or like 7zip. Many other tools are there. These are all called into compressed mode. And you want to say that encryption, there are many kinds of cryptography encryption algorithms are there. So using those algorithms, you can able to provide some kind of encryption. Now, whenever you are going for compressed form, you please take care that whether you are sending into lossless formats or whether you are sending into lossy formats. For example, if I am sending a BMP file, this is a lossless. But if I am compressing into GIF format or PNG format, they are lossy format. So you are downloading something from YouTube, and there are three varieties you are going to get: 720 and 360. If you are using a 360, it is a lossy format. If you are using a 720, it is a lossless format. The size of your audio and video is also going to be high, especially audio and video formats. Now let us see its responsibilities and functionalities. Presentation layer, it's also involved only in software. It provides a function called exchanges between your layers and operating system. It defines the format that is being sent and any encryption that may be used, and it takes a presentable to the application layer at the receiver side. And the presentation layer is also following a PDU, which is encrypted or compressed message. So we already learned what are the functionalities of them: translation, encryption, compression. These are the different varieties of tools which are there for presentation layer. So when you go for the next layer, because you know that how the data is coming, whenever you are sending your data from application layer, it comes to the presentation layer. That means with the help of service data interface of your lower layer, it is going to put in the form of a payload. So the payload will come here. And this payload consists of your original message and the header which is there of your application layer. And the presentation layer takes that payload. This payload consists of your data and application layer header, and is also going to attach the header of your presentation layer. And this data format will come to the next layer. Now the next layer is going to take in, that is a payload, which consists of your PH and AH and your message. And now this is done by your session layer. So what are the responsibilities of the session layer and functionalities of the session layer? I will give few examples once. When you are downloading something, when you are downloading some movie or image, whatever it may be, I'm downloading, or some attachment. When you are downloading something, it is going to show a progress indication: 0%, 10%, 20%. This is one of the responsibility of your session layer. And whenever I say that once your download got completed, then you will get a message whether your download is a success or your download is a fail. Both, either message you are going to get. This notification message is the responsibility by session layer. So whenever I say that I have downloaded some movie from your YouTube or some other medium, which is of 700 MB. I started downloaded. It is downloaded successfully up to 699 MB. Downloaded success. But you cannot use them, it is in the form of crawl file. Therefore, we want to see that up to 100% is supposed to be completed. And exactly here, net connection failed. So whenever you see that net connection is a fail, we want to restart it. So when you restart your download, when restarting of download, you all may face this kind of problem. Then our download starts from please give your comment whether your download starts from 699 or your download starts from starting position. Please comment to me if you know this or if you are experienced. So I already experienced, many times I experienced whether your download is starting from 699 or starting position. This is done using, some people will say that it is a 699 MB and some people will say that it is a starting position onwards. When you download from starting position, your bandwidth is fully wasted. There may be a chance that in middle your connection may be lost. Again you need to re-download it. This is how we are consuming our bandwidth. So this problem can be avoided with the help of session layer. What the session layer is going to do, it is going to create a synchronization points. I am calling them as a checkpoints. These are called synchronization. So according to the synchronization points, it says that this is a success. Therefore, whenever you restart your download, then your download is going to start from that particular point only. Otherwise, you are going to restart your download from starting position. What is the real-time application of this? Whenever you talk about this kind of features, what is the real-time application of this? If you are using Internet Download Manager, IDM is inbuilt using session layer. That means your download never goes anywhere. It's going to create a sync point. So it is going to start from your 699 MB only. And the other application is called Torrent software. If you are using Torrent downloads, then it is also inbuilt is using a session layer. So this is how you can able to automatic checkpoints are being created for every successful download and upload limits. So these are all the one of few of the responsibilities of your session layer. Session layer is also responsible for remote connections. So what is the real-time example of this remote connections? We all know AnyDesk and we all know TeamViewer. So you want to establish a remote desktop connection, then there is a requirement of some virtual session. So those virtual sessions is also responsibility by session layer. And is also responsible for dialog control. It decides whether your data transmission is off duplex or full duplex. This is also another responsibility of your session layer. And purely session layer is completely doing with the software only. These are all completely software tricks, and it is a software based. So let us see what is the session layer. So when you talk about the session layer, it's a software based. It defines how data conversations are started, controlled and finished. And the session layer manages authentication, authorization. And the messages may be bidirectional, full duplex if I am talking. and indications that show that whether packet is in the middle or at the end of the conversation. And a session layer PDU is in the form of encrypted and compressed messages. So what are the responsibilities? The responsibilities are dial-up control, sharing your connection, and providing a synchronization point, establishing a logical session or virtual connection, and flow control. Flow control is done using a token mechanism or token exchanging and a connection sharing. For example, there are multiple nodes are connected to your medium like this. So it decides the token management system who has to send first and who has to send next. So that's the flow control. And what is the next layer? Transport layer. And if you talk that OSI is divided your higher level layers into three parts: application, presentation, session. These three are combined together in TCP/IP. Why they are combined together? Because they are purely end to end. They never deal with media except firewall and gateway. And these three are completely software approach. See the common properties. End-to-end layer, not deal with medium, and they are purely software based, and purely they are embedded in your software applications and packages. Therefore, my dear friends, they have been combined, and in TCP/IP, we are calling all together as application layer only. So all the three functionalities whichever happening in the OSI, that is happening in application layer. And the next variety of layer is end-to-end layer, transport layer. So what is the transport layer? First let us see. It is basically believe in port-to-port communication. It is going to hand over your data to exact port at other side. For example, if sender is transmitting data with the help of HTTP and TCP, and transport layer is at other side receiver, using TCP, it exactly hand over the data to HTTP, not to anybody else. That's why it is also called as a process-to-process communication. MUX is happening at sender side, DMUX is happening at receiver. So my dear friends, so transport layer is a mainly responsible. Exact process communication is done at the side. Therefore, it is end-to-end and port-to-port because it deals with a port address. Transport layer is a completely deals with a socket address, and your socket address is consisting of port number and IP address together. And its PDU is a segment. Its PDU is a segment. Down the layer, it is providing the data unit in the form of a segment. And upper layer, it is providing the data in the form of a bytes. Because it is a byte-oriented protocol or layer. So the down layer, it is providing data in the form of a segment. To the upper layer, that is application layer, it is providing the data in the form of the bytes. And these bytes are further being formed into a message. And many responsibilities are there with TCP transport layer, that MUX, DMUX, encapsulation, decapsulation, pushing and pulling, and flow control, error control, congestion control, timer, and connection oriented, three-way handshake, many other are there. These are all responsibilities of your transport layer, which is running TCP, UDP, and SCTP. So it is also purely software based. It do not involve with any kind of intermediate nodes. It is an interface between uppermost layers and lowermost layers. And its PDU is in the form of a segment. A segment consists of bytes of data. It provides the lower layer in the form of a segment and a higher level data in the form of a byte. And every byte is assigned with a unique sequence number. So you all may ask a question, what is the meaning of a segmentation? What is the meaning of a segmentation? CPU can able to understand data in the form of segment only. So whatever transport layer is communicating two-way, because the transport layer is a full duplex two-way, and they are going to be communicated in the form of segment only. You are sending data means you are sending a segment. He is sending a data means he is sending a segment to you. A segment consists of group of bytes. I will show you one important example. Please see. Application layer sends 1000 bytes of data. When it comes to the transport layer capacity is not unlimited like your application layer. Application layer capacity is unlimited. That's one of your important gate question. How much data you see that? As much you can able to send at application layer, but transport layer there is a restriction. According to your default transport layer, 65,536 bytes you can send at a time. But let me take analogy, not that much. I am taking application layer is sending data 1000 bytes, but transport layer capacity is only 200 bytes on. So how this is happening? And transport layer takes this 1000 bytes of data and it is trying to number them. Each byte is going to be numbered. Starting number always starts with 0. Ending number is always end with n-1, 999 bytes. Now your transport layer segment capacity is only 200 only. Now the segment consists, as I said, 200 bytes of data. First segment I am releasing from sender to the receiver. And this is a consist of 200 bytes, which is of 0 byte to 199 bytes. Altogether it is 200 worthy. Now this arrow, what I am representing, this arrow is nothing but segment only. This is one of your segment because a transport layer can understand only data in the form of segment, not in any kind of format. Because each layer has got its own PDU only. I cannot understand format or a message or a frame or bits. It understood only segment only. So I am releasing the segment. And every segment is also require a number. Please understand. This is one of your gate question. First, we are allocating the numbers to your bytes after receiving your 1000 bytes of data. And now your segment got number. What is your segment number? Your first byte number is your segment number. So your segment number is 0, which consists of 200 bytes of data. Now you are sending us next segment. Your next segment is a what, my dear friends? After 199 bytes, we are going to get next segment. That is nothing but S200. If you know the 200 at the segment you are sending, I know that what is the first byte number. The first byte number is your segment number only. Therefore, which consists of 200 byte 2 and plus 200, which is nothing but n-1. So I am sending up to 399 bytes. And your next segment is S400. And your next segment is S600. And your next segment is last segment, which is S800. This is how, my dear friends, the segments are being transmitted from sender to the receiver, and the segments are being numbered. Segment number is nothing but starting byte of your number only. Therefore, I am giving you one important gate question which I want to discuss. So this is one of your gate question. Sender sends two segments to the receiver. One is a S80 and one is a S95. He is asking how much data is there in SAT segment. In SAT segment, how much data is there? If you know answer, please reply to me. How much data is there? How much data bytes are there? So our answer is simple. What is that? The difference between this segment and this segment is a 15 bytes. So your segment of your SI consists of 15 bytes only. And you know the segment number, I know the first byte number. What is it? 80 byte. And before that number only your answer, that is nothing but 94 byte. So your starting byte is a 80 byte, ending byte is a 94 byte. Altogether 15 bytes it is. So this is one of the transport layer responsibility. And what are the functionalities? Process to process communication, exact application layer protocol, it is going to deliver the data. For example, you are sending a mail, it exactly put it to the SMTP only. And end-to-end delivery, it doesn't mind any intermediate nodes. Ordering of data, one segment after another segment after another, it will come. Pushing and pulling, multiplexing and demultiplexing, and addressing, and segmentation and reassembly of segmentation, and connection control. It is a following three-way handshake. It is a following a three-way handshake. And it is also going for flow control and error control. Flow control and error control is done using go back and selective repeat protocols. Transport layer is following these two protocols together, and it is also following a congestion control with the help of AIMD approach. It is also deals with the timers. It is following a virtual circuit. And if you are using a UDP, then if you are following a TCP, it is a virtual circuit. If you are following a UDP, then it is a datagram. So this is how about transport layer, my dear friends. Basically, it is an interface between your topmost layers and bottommost layers. Don't forget that. And the next layer is internet layer, which is not completely software based. It deals with the hardware also. One of the hardware device which is dealt by network layer, please comment if you know the answer. That's why it is a software and hardware based because it deals with the medium. It is a IP to IP data transmission. Direct, I know that who is the source and who is the destination, I know. That's why it handovers data to IP only, called as host to host delivery, point to point delivery. And it's also following a protocol data unit, which is IPDU, Internet Protocol Data Unit, are also called as Network Protocol Data Unit in the form of packets. Transport layer PDU is in the form of a segment, and Internet layer PDU is in the form of packet. And every packet is going to give a unique sequence number. In transport layer is also every byte is going to give a unique sequence number. And it is also going to attach a header. Transport layer is also going to attach header. What is the header size in your transport layer, my dear friends? The minimum header size is a 20 byte and the maximum header size is 60 byte. Internet layer is also minimum header size is a 20 bytes and the maximum header size is a 60 bytes. Header is a mandatory at every layer because we are doing a peer-to-peer process. The meaning of peer-to-peer process is nothing but attaching a headers to your upcoming or received payload. And this can be connectionless and connection oriented. And what are the responsibilities? Construction of packets. Fragmentation, another important responsibility. It deals with IP addressing. It deals with IP address, and it is involved in a routing, and it also deals with the congestion detection and control. This is the common responsibility of your transport layer and internet layer. That's why your OSI got not implemented, because the functionalities and responsibilities are not defined clearly and redundant responsibilities in OSI. So these problems are avoided in TCP/IP and decide that this layer responsibility is this and this layer responsibility. And the next one is data link layer. So up to whatever layers we learn, once let us execute like this. There is a sender. Please go through my previous videos to get the clarify about this example. He sends the data. First it comes to the application layer, and it comes to the next presentation session, and comes to the transport layer, and next comes to the internet layer. And we were discussing up to this point only. That is a full stop there. And this is an end-to-end layer. Directly it will interact, and the protocols which is running at application layer is different from other layers. And this is also end-to-end layer. It is running with major TCP and UDP. Nowadays we are also been learning stream control protocol, which is offering a transport layer. And they are end-to-end and only. End-to-end in the sense they never interact with any medium. See that directly they are interacting with the receiver only. But whenever you talk about the internet layer, it is not directly is interacting with your others. It is going to interact with a device called router. If you add a router as a device here, it is going to provide a shortest path with the help of a router is inbuilt running internet layer, because router is a 3-layer device. Therefore, this internet layer will contact this router. This router is running internet layer. This internet layer is providing a shortest path. From there, data will goes to the other internet layer. From there, it goes to the upper layer. From there, it goes to the other upper layer. This is in the form of a message. So other side also in the form of message only it can understand. This is in the form of a segment. This is also in the form of a segment. What are the common principles between your application presentation, session and transport? They are end-to-end layers and software based. But internet layer is a deals with a medium, because a router is a medium. A router is a hardware medium. Here, my dear friends, and while you are transmitting your data, application layer has got app address. Please listen carefully. Every layer has got its own addressing format, and transport layer has got socket address. And internet layer is looking for, you all know, IP addressing. So this IP addressing is not going to be changed during data transmission. From address and to address is fixed. From address and to address is fixed. And your socket address is also not going to be changed. So this is how so far we learned. Now let us look at into next layer, that is the data link layer. It's a software and hardware based. Data link layer is a link. That's what the meaning of link layer. What's a link layer? I know about my next link only. That link knows only about the next link only. That link knows about the only next link only. That's why it is a hop to hop based, or a MAC to MAC based, or link to link based. Its PDU is a DPDU, data link layer protocol data unit, which is in the form of a frame. It delivers the data to the next link only, not to the others. I know about my next link. and every frame is attached with a header and trailer. This is important. Trailers are attached only in the data link layer, and remaining all layers up headers are attached, but data link layer trailers are also attached. These trailers are responsible for error detection codes. With the help of trailers, I can able to detect the errors which are there in your particular frame. But a header is a mandatory. Why? Because this will tell you that who is the source and who is the next link address. That's why headers are mandatory in every layer. And your minimum and maximum frame size according to the Ethernet, I am talking Ethernet, like your LAN, 64 byte to 1518 byte. In that, your header size is also included. So what is your header size? 18 bytes. That means 14 bytes header, 4 bytes trailer. 4 bytes trailer. These are all important one mark gate questions, my dear friends. So I will conduct a questionnaire on Unacademy Learning app after completion of these basics. So by tomorrow we are going to complete our basics. After that, I will start data link layer. Then before that, we are going to solve special class for practice questions on your fundamentals and layer structure. And there are other responsibilities are also there with the data link layer. They are every frame is associated with a number, and it removes the transmission errors and virtual communication path it involves. Why? Because from upper layer to data link layer, you talk about from application layer to data link layer, they are not participated physically, they are participated logically only. Logical communication. Who involved in the real-time communication? Only the last layer, bottommost layer is involved in real-time data communication. And its main responsibility is construction of frames and deals with the MAC address, error detection correction, low control, error control, service provided to network layer, because lower layer has to provide the services to upper layer. Even the same is there in network layer also. 3 has to provide the service to upper layer. It mainly deals with the MAC address. What is the MAC address? MAC, medium access control address. Medium access control address, which is fixed to every system, which is unique in the world, which is measured in the form of 2 power 48 bits. This is your MAC representation. When you talk IP representation, so I said that IP address. The IP address is in the form of 2 power 32 combinations. Your logical address according to IP version 4, which is of 2 power 32. According to IPv6, it is a 2 power 128. And what is the responsibility of your data link layer? For example, I say there is A and there is a B, C and D. So I am talking perspective to data link layer only. Please recollect yesterday's my lecture. Who is the hop to the A? A is the source now. Who is the destination to A? Source address is A and destination address is B only. Actually, your destination is D. Your source is A according to internet layer, transport layer and application layer. But data link layer do not know that who is D. Data link layer only about my next link only. So therefore, your source is A and your destination is a B. As soon as it comes here, and B got reacted, I am the source. My destination is a C, because I know only up to my link, next link only. Therefore, the data has passed here. And now here C is differently thinking. I am the source. My destination is a D. And data is passed to and D thinks that I am the destination. So therefore, the data goes to internet layer. So you got the data from internet layer to data link layer. So this is how MAC address. MAC address every time is going to be changed. This is your old MAC. This is your destination MAC, and this is going to be your new MAC. This is going to be your destination. So what do we understand, my dear friends? IP address doesn't change during data transmission. Very important bit. IP address do not change during data transmission. That is a fixed. But what is changed? MAC address is changed. MAC address is changed at every hop. Because they are taking a different sources and different destinations. And the last layer is a physical layer, which is an interface to the media. Which is an interface to the media is a physical layer. Interface to the user is application layer. It is mainly based on line-to-line communication. Its PDU is a PPDU in the form of a bits. And it's a purely hardware only. Data link layer somehow it is satisfying software also. But physical layer is a purely what? Physical layer is a purely hardware nature. It deals with the physical characteristics of the medium. So it is interfaced to the medium. So it ensures that bit synchronization and places the binary pattern that it receives into the receiver's bus. It deals with the physical characteristics of the medium. And there are many functionalities are there, my dear friends. It is involved in actual transmission. Upper layers are involved in virtual or logical communication. Deals with the physical characteristics of the media. What is the bandwidth? That's a physical characteristic. What is the topology? And are you using a wiring or wireless? And what is the transmission technology? Your medium is a shared or dedicated. They are all physical characteristics of the medium. So encoding and decoding is another responsibility. Data rate, which I am talking about, bandwidth and throughput, and the synchronization of bits, transmission technology, communication mode, off duplex or full duplex. This is a one-to-one or one-to-many. And next functionality is a transmission modes. And next functionality is a line configuration. And next is circuit switching, because the physical layer is involved in the circuit switching. Please recollect the circuit switching lecture, which I already taught. And the multiplexing, hardware mux and hardware demux. You know what is a mux and demux? When there are multiple input lines are there, but only one output line is there. What is going to happen? They are being compressed together. They are being compressed together as a single line. Actually, there are three lines. They become as a one line. And in this, the data is being transmitted. Finally, it is releasing to exactly demux. So it split into three data transmission lines. So here you are seeing that mux multiplexing. Here you are seeing that demux. It is done by multiplexer component. So media and modulation, modem modulation and demodulation, transmission medium, and the topology identification. These are all the responsibilities of your physical layer. So my dear friends, before closing this session, so observe carefully one sender and receiver. I already shown you application, presentation, session, transport, internet, data link, physical, physical, data link, internet, transport, session, physical, application layer. Now listen, they are communicating with the help of peers. and they're all end to end, we know. But these three are interacted with the medium. Don't forget that. These are interacted with your physical medium. That's why they are being called as hardware support layers. Hardware support layers, also called as layers interconnected. They are interconnected layers. And finally, the physical layer is trying to transmit the data to other physical layer. And each PDU is different. Its PDU is APDU, its PDU is a TPDU, its PDU is a IPDU, its PDU is a DPDU, its PDU is a PPDU. And each layer is running its own individual protocols. And next important point is a layer. This is a layer number 7. Can communicate only with layer number 7 only, no cross communication. Layer 6 can communicate with layer 6. Layer 5 can communicate with layer 5. This is how it happens. That's it, my dear friends. So this is how about the responsibilities of a layered structure. And in TCP IP, it becomes into 4 layer. All three, application and presentation and session together is a combined. Transport layer is a like that. Internet layer is a like that. The bottommost layers are combined, data link layer and physical layer, as they are link to link based. Observe carefully. Both are link to link based. That's why, because of these two common characteristics are there in DLL and PL, they are combined. Because of these three are software oriented, they are being combined. So when you talk this kind of a structure, it is TCP IP. Why OSI got outdated? Because redundant functionalities and redundant services. TCP IP is eliminate the common functionalities except congestion and error control, remaining all are dedicated functionalities. So this is how you see that how the functionalities are happening at each layer. So please subscribe our Unacademy YouTube channel, my dear friends, and please like all my videos. Share this knowledge to all your friends. Give a like. Your like is a big applause to us, so we can able to prepare much more content which is beneficial to you. And tomorrow our responsibility, that is tomorrow our session is going to start at 10 only. Our concept is what are the differences between hub, switch and the router. So we will discuss. After that we will start data link layer. So stay tuned to Unacademy, and please take a subscription into Unacademy using my referral code. By using my referral code, you are going to tag it to me. So my referral code is Sankara. Then by using this referral code, you are going to get a maximized discount. And you are going to be tagged to me. So I'm going to take care because as you're under me. Thank you very much, my friends. Good night.